The question that I have is, could you explain friction from a mechanics point of view? We all have some understanding of friction, right? I'm sure you have learned some aspects of friction either in your high school physics or your college physics, right? I'm sure you have learned of Coulomb's friction, right? Say we have a block sitting on a frictional surface like shown in this picture. The block is subjected to a force N normal to the frictional surface. If we were to make this block slide on the surface by pulling it horizontally with the force F, the magnitude of the force F will have to be raised to a value given by this equation, right? F equals mu times N. And this is what is called the Coulomb friction law, where mu is the coefficient of friction. Mu depends on both material forming the block as well as the surface, right? I'm sure you're all familiar with Coulomb friction law, right? So let's start from here. So anytime there are two bodies that are in contact with each other on a surface, there is going to be friction. We're going to have to deal with this. In mechanics language, we're going to have to quantify. In civil and mechanical engineering fields, we run into all kinds of machines and structural arrangements. So it turns out there's a lot more to dealing with friction than what is involved in the simple sliding block model. For example, the mechanism movement of one body relative to the other could be different. To make my point here, let me take this sliding block model one more time. If the block is a short block like shown in this picture, and you pull it sideways with the force F, the movement of the block is going to be more than likely sliding on the surface. But let's say we have a block that is kind of tall like shown in this picture. We are pulling the block horizontally by holding it at the top of the block like in this picture. Then it turns out the likely mechanism movement of the block is not going to be sliding but tilting like shown in this picture. Now try to remember experiences you might have had in your own life. For example, let's say you have a refrigerator sitting in your kitchen, right? Let's assume that the refrigerator doesn't have wheels on them. Now you're trying to move the fridge, right? If you hold the fridge somewhere near the bottom and pull it, it's going to start moving by sliding, right? On the other hand, if you hold the fridge at the top of the fridge and pull it, it's more than likely going to tilt. So it turns out that the horizontal force that you need to apply to the fridge in order to move this is going to depend on whether it's going to slide or tilt. So we're going to have to first determine whether it's going to slide or tilt and then come up with a way to calculate the force that is needed to make that happen, make the block move. So problems involving friction come in different forms. In these problems, we may encounter different mechanisms. The contact surface between two bodies could be of different shapes, like for example, it could be rectangular, it could be circular, and so on. The contact surface could be undergoing different motions, like for example, here we have a linear motion, right? But in some cases, we may have a rotational motion. So look at some of these problems in this course and see how we can solve them.